Bueno, buenas tardes. Muchas gracias por asistir al taller. Mi nombre es Esteban Bilbao y soy socio de la regional Necochea y voy a ser el moderador del taller. Les pedimos por favor que silencien o apaguen los celulares y les recordamos cómo es el funcionamiento. Es una exposición de alrededor de 20 minutos y luego tiempo para preguntas. Por favor, para hacer las preguntas levanten la mano y les vamos a alcanzar el micrófono para que salga todo grabado en la filmación que va online. Así que bueno, les voy a presentar a Wayne Smith, es de Australia, es un economista, consultor en agronomía independiente, en agricultura basada en siembra directa y tiene una amplia experiencia en lo que es brindar disertaciones en Australia y en el resto del mundo también. ¿Sí? Wayne, please.
Hello everybody, welcome from Australia. Hopefully you can understand the Australian accent in Spanish. I'm going to talk about learning plant language. Now when I went to university, we get taught what is the textbook example of copper deficiency or zinc deficiency or sulfur deficiency. But in the real world, it's not the real case, is it? Because in the real world it might be waterlogged, it might be too cold, too hot, it might be sulfur deficient and zinc deficient, and it might have root disease. So when I'm out of university and I go out into the paddocks and I think, look at my textbook, I get confused because it doesn't look like a textbook. The real world is a bit like this. We can have a textbook example of what something should look like, but in the real world it's a bit more complicated. But there is still a way of knowing what's wrong with a plant. So how can you diagnose a crop when you have three things wrong? I'm going to show you this photo at the end of the talk, but that looks nothing like textbooks. But there are three things wrong with that, and hopefully I'll give you a little example of how to know what's wrong. I teach this learning plant language in half a day, so you're getting a very small version, and then we normally go out into the paddocks and put it into practice. Hopefully one day I can come back and do a longer version for you. But it looks a mess, but the plants do tell us what is wrong. There is a way to know what is the number one problem, the second problem, the third problem. The plants do talk to us. I call it learning plant language. Now all this began in 2006. I went to America in Kansas and an agronomist was showing me around. And I was surprised because it's like, you have really bad zinc deficiency, or this is really bad copper deficiency, and it's sulfur deficient. And he didn't believe me. He kept on saying, Wayne, you're from Australia. You don't have winter kill. This is winter kill. And I go, no, this is sulfur, this is zinc, etc. Anyway, 2 weeks later, I'm back in Australia, and I get a phone call. And he says, Wayne, how on earth did you know what's wrong with the paddocks? I don't know, I can tell, you just have a look. Because where I come from, we have a lot of sand. It's deficient in everything except silica. Now, that can be depressing where I come from, so we call it silver loam. It makes us feel a lot better. So, I don't have time to show you what everything looks like in a crop, what the deficiencies are, but I will show you some examples, and then I'll show you how to learn what's wrong with a plant. So textbooks can be confusing. Textbooks don't always show you what's real in reality. So for example, in my textbook, this is what zinc deficiency looked like. It's meant to be two parallel dead lines, but that is very rare. That almost doesn't happen. Zinc deficiency normally looks like this. The bottom leaves are better than the middle leaf. The top leaves are better than the middle leaf. And in the middle of the middle is lesions. Now you might think that's leaf disease. No. Leaf disease starts on the bottom leaves. Leaf disease does not start in the middle of the middle. This is zinc deficiency. So here are some more examples of what zinc deficiency can look like. You might see a crop like this, but there are lesions in the middle leaves. It is not leaf disease. Leaf disease starts on the bottom leaves. Anything like this in the middle of the middle is zinc deficiency. Another example, this one is in Kansas, in America. It's one of the first paddocks I walked into, and I said, wow, I didn't realise you had really bad zinc deficiency. In my mind, Kansas, biggest wheat producing state in America, they must be really good farmers. They're not. Lots of dead lesions in the middle of the middle leaves. That's zinc deficiency. But it can get more confusing when there are two things wrong, and I'll give you an example. This is zinc deficiency, where there's lesions in the middle leaves, but hopefully you can see that this is darker green down the bottom, and it's paler and erect at the top, which is sulfur deficiency. I'll show you that later. So it looks nothing like textbooks, but it's still dead lesions in the middle leaves, even though there's something else going wrong. Here's another example, a zinc deficiency, but it's also manganese. Manganese I won't talk much about, but manganese deficiency is all pale, all floppy, all the leaves are floppy. But you've still got these lesions happening in the middle leaves. A bit hard to see in that screen. But middle of the middle is zinc deficiency. As this summary is there. Middle of the middle is what I want you to remember. Leaf disease, it looks like leaf disease, looks like septoria, but that starts on the bottom leaves. Doesn't start in the middle of the middle. Copper deficiency is another example of where textbooks don't always show you what reality is like. For example, this is in Kansas. Again, a paddock I went into and said, wow, you've got really bad copper deficiency. And he goes, Wayne, I've told you before, this isn't copper deficiency, this is winter kill. I go, no, this is copper. All deficiencies get worse at the bottom and get better as you go up. Copper's the opposite. It's worse at the top and gets better as you go down. So this is the top leaf, the newest leaf, and it's dead and it's twisted. It will always be twisted. If you see a dead tip and it's sticking straight out, it is not copper deficiency. Copper will always bend and twist. And the next leaf down is better than that one. But please notice that. That is also abnormal. That shouldn't be there like that. Copper deficiency is dead at the tips and twisted. Worse on the top leaf. That's textbook example. Here's another example in oats, where all the top leaves are dead and twisted. Again, if it stays like that, that is not copper deficiency. Copper deficiency will always bend and twist over. Looks a bit different to what I showed you before, but it's still the top leaves. When I run the learning plant language workshops, I show everyone textbook copper, textbook zinc, textbook sulfur, etc. Then the very first photo I show them is this one. And they're like, you didn't show us anything that looked like that. But that's because I want to show them real world examples. So in this one, everything is dead at the tips, but there is something very different happening at the top. And notice the top leaves are twisting. That's the key. This is severe copper deficiency, but there's still a consistency that copper is dead and twisting at the top. If you sent me a photo of this, saying it's dead at the tip down here, that is not copper. Copper is always at the top. If you have a hot wind and the top of your leaves go black or get burnt after a hot wind, that means it is copper deficient. And the reason being is that copper converts nitrates into protein. It's one of its roles. So a plant takes nitrogen up, always to the top. Along comes a hot wind, sucks the water out faster than it can be replaced, and it becomes nitrate toxic, and it burns. So if you ever see this happening after a hot wind, burning and start twisting, that's copper deficiency. Doesn't happen with it unless it's copper deficient. This is an example of textbook sulfur deficiency. Textbooks say bottom leaves green, top leaves pale and erect. But I want to show you how to pick that up earlier. That's what textbooks say. Also want to point out that because with sulfur you only need a little bit to make a plant happy. You can have one plant looking greener in amongst the other sick ones. If it was nitrogen, you'd have a cluster, a group of plants looking good. With sulfur, you can have one plant looking good because you only need a little bit. So that's a key thing to look for in the field. So the levels of sulfur deficiency, the very, very first symptom you see is this. If you walk into a wheat paddock or barley paddock and the leaves are doing this, that's a bad sign. Vertical is always bad. It means something's wrong. If it's common for you, then you've got commonly something's wrong. The first thing you see is vertical leaves. The second level, as it gets worse, is a very interesting symptom. You get red on the stem, up off the ground, and only on the side of the sun. So for us, southern hemisphere, it's on the north. If we were in England, it would be on the south side. As you get worse deficiency, it becomes the top leaves are pale, the bottom leaves are green, like textbooks talk about. But I want to teach you how to pick up the number 1 and 2. And then if it gets really bad, the plants don't even respond to nitrogen anymore. So this was a paddock I went to in New South Wales in Australia. As I walk into a paddock, if those leaves are vertical, which those top leaves can't quite see it, but the top leaves are vertical, a bad sign. Usually it means sulfur deficiency. As sulfur deficiency gets worse, you start seeing this very strange symptom. Notice there's red on the stems, but at the bottom it's green. I'm going to explain phosphate deficiency later on. Phosphate deficiency is red at the bottom, but sulfur is red up off the ground. Now the next photo, I'm going to put my hand behind it and take the photo, and it's all green. It's only red on the north side. That's level 2 of sulfur deficiency. So this is really bad sulfur deficiency. And you can get clusters that would be like a nitrogen or lots of other fertilizers. But hopefully you can see there are single green plants. If you look out into a paddock and you see a single green plant in amongst pale erect ones, it's sulfur deficiency. A good agronomist just keep on driving, doesn't even have to hop out of the car. This is in Kansas, and again, I walked into the paddock and said, wow, you got really bad sulfur deficiency. And he goes, Wayne, I've already told you. This is winter kill. You don't get winter kill in Australia. And he said to me, look, you can even see the line of the frost. And I said, no. Sulfur deficiency is pale at the top, green at the bottom, but you can see individual, like here, individual green plants. If you see one green plant and all the rest is pale and erect, that is sulfur deficiency. Another example, this is barley. All the top leaves are pale and erect, greener at the bottom, but notice in amongst it you've got one better plant because you only need a little bit of sulfur to make a big difference. Now, when I run the learning plant language workshops, I show this photo right at the beginning and then I show it again at the end because most people will say nitrogen deficient, and no, it's not. The plants are telling you a very important clue. And the clue is, remember, vertical is bad. These leaves are far too vertical. And there is leaf disease, but it's really hard to see on this. But the second symptom of sulfur deficiency is starting to be seen. There's just a little bit of red on that side of the stem, and it's just starting to go a little bit red, always on one side, always on the north. So if you walk into a paddock and you see vertical leaves, it's probably sulfur deficient. You might only need 5 units per hectare to fix it, but that's the first symptom. If this was just nitrogen deficient, those top leaves would be flopping over and you'd be yellow at the bottom, but it's not, it's vertical. The plant's telling you the number 1 problem is sulfur. And then you would add more nitrogen. And now I want to teach you some techniques of learning plant language, because I don't want people just to learn textbook examples like looking at pictures all the time. You have to diagnose it yourself. So I want to teach you a few tricks. When you spray a herbicide and it hurts the plant, that means something. Take notice of where it hurts the plant, because it will show you what is wrong with the plant. If the crop is healthy and you spray the herbicide, nothing will happen. So if you use a herbicide here in Argentina that hurts the plant, have a look where it hurts the plant. It will mean something. As a consultant, I love using UAN, urea ammonium nitrate, and diflufenicin mixes. I don't know if you have diflufenicin here in Argentina, but it hurts the plant if something is wrong. If the plant is healthy, it doesn't hurt it. I'll show you some examples. So back to this photo at the beginning. This was sprayed with UAN plus diflufenicin. I want you to remember something. every leaf got hit. The herbicide didn't just land where it hurt in the plant there. Every leaf got hit by the spray. What it's showing is zinc deficiency, because where the plant is weak is where it will be hurt. So those three things that, if I had more time I'd show you properly, but there's a lot of paleness and floppy, that's manganese. The number one problem is zinc deficiency, it's being hurt in the middle, but you will see plants like this, little bit of red on the stem, and that new leaf is vertical. Vertical is bad. So you've got manganese deficiency, zinc deficiency, and sulfur deficiency. The plants will show you. Remember, this is another example of spraying with a diflufenican brew. Remember, every leaf got hit. The spray did not just land there. Here's the bottom leaf. Here's the next leaf, middle of the middle. Top leaves are better. Middle of the middle is zinc deficiency. The herbicide will show you. I'll go back to that, sorry. If I hadn't sprayed the brew, I would not have known it's zinc deficient. By stressing the plant, it shows up what's weak. So as an agronomist, I deliberately recommend diflufenican brews because it makes me get it right more. Not so much the farmer. Another example. This was sprayed with the diflufenican brew. And in my early days of consulting, I went, aha, look, it's just hurting the middle of the middle leaves. That's zinc. I recommended the farmer go and spray zinc. About a month later, it was like, oh my goodness, this is really bad copper deficiency as well. And fortunately, I had taken a photo. If you have a close look, you can see the tip of a new leaf is all bleached. Remember, every leaf got hit. Why is it only bleaching in certain spots? Because that's where the plant is weak. The tip of the new leaves is copper. Middle of the middle is zinc. So I should have recommended copper as well. I'm going to teach you a little bit more about phosphate deficiency in a minute, but this has got no fertiliser, and this has got fertiliser at seeding. Very small, stunted with no fertiliser means it's phosphate deficient. But I want you to notice something. This was sprayed with a diflufenican brew, but any herbicide that hurts the crop. There's almost no bleaching where there's no phosphate. But you add phosphate, and now you start getting bleaching on the tops of the new leaves. Because the plants will show you what's number one. You fix that, it will now show you what's number two. Number three, it's got nothing to do with calcium-magnesium ratios. The Liebig model works. What's the most limiting? Then the next. So as a consultant, I recommend people fix the first thing first. Don't try and fix everything. Just fix what the plants are telling you is number one. Then fix the next. Then the next. So if you only remember one thing from today, I want you to remember this, is turn your phosphate fertiliser off at seeding time. This is the number one way of learning what's wrong with your plants. Turn the phosphate fertiliser off. And, of course, have a double dose. And I'll explain why in a minute. So when you turn your phosphate fertiliser off at seeding time, where there's no fertiliser, if it's one colour, it means there's one nutrient thing wrong. If, where you've turned the fertiliser off, it's multicoloured, it means there are two or more nutrients wrong. Very simple thing. Now, if where you have turned the fertiliser off, let's say that's the height of the row where you have put fertiliser. And where you have no fertiliser, the plant's only this high. Okay, if it's less than half the height, it means it is, number one problem is phosphate deficiency. If the plant is, say, up to here, more than half the height, phosphate deficiency might still be an issue, but it's not the number one. So if it's below half the height, phosphate deficiency is number one. This works with any phosphate fertiliser. So remember those rules. Where there's no fertiliser, one colour, one problem. Multicoloured, two or more things are wrong. If it's less than half the height, phosphate deficiency is the number one problem. If it's more than half the height, something else is more important. So when you turn the fertiliser off, it's going to show you how much phosphate you needed in the crop, but it's also going to show you what the next problem is And usually it will show you what the third thing is wrong. Now, if you never turn the fertilizer off, you will not learn this. I'll show you some good examples of this. And it works with any phosphate fertilizer. It doesn't matter if it's MAP or it's a phosphate with sulfur plus trace elements. It doesn't matter. As long as it's got phosphate, this works. So first of all, I'll just teach you phosphate deficiency in wheat. It's short, upright or vertical leaves. Nearly all the leaves are vertical. You have a red at the base of the stem. Remember, sulfur was up off the ground. Phosphate is at the base and it goes all the way around the stem, and you have very poor tillering. So here is an example of textbook phosphate deficiency. It's red at the base, every leaf is vertical, there's no tillering, and it's very small plant. That's phosphate deficiency, textbook. I love it when clients make mistakes because I learn a lot. This client forgot to put the fertilizer on, turn the fertilizer on. Now, that is pretty much one colour. One colour means one thing wrong. Those plants are less than half the height of these rows. So less than half the height means phosphate deficiency is the number one problem. Pretty much the only problem. The plants have told you. If you had your whole paddock looking like this, you would not know what the phosphate level is like until you turn it off. But it gets more important than that. This is a client bought a new farm. Now he's having lots of trouble. There's meant to be a tine in there, but it fell off. There's no fertilizer in there, and this has got the fertilizer. So that is less than half the height, which means number one problem is phosphate deficiency. The next paddock, this is 100 metres away, across the fence. These two rows had fertilizer blockages. There's no fertilizer there. But hopefully you can see it's more than half the height. So that means it is not phosphate deficient. In this case, it's potassium, but I don't have time to explain why. But by turning the fertilizer off, it tells you if you needed more phosphate or not, and it tells you what the second thing is wrong. If you don't turn the fertilizer off, you don't learn that. This is the two most important slides of today's talk. This is a fertilizer the client used. It had everything in it: phosphate, nitrogen, sulfur, copper, zinc, manganese and molybdenum in every granule. And I love mistakes. He had fertilizer blockages. It's wonderful. A couple of things to notice. Where there is fertilizer, that is too vertical. Vertical is bad. Where there is no fertilizer, it is multicoloured, which means there's two or more things wrong. I don't have time to show you a lot, but all these pale floppy areas, that's manganese deficiency. A lot of the other areas there you can't see in the photo is zinc deficiency. Now remember, the fertilizer had zinc and manganese in every granule. So let's have a close look. This is the row without fertilizer, and that's the row with fertilizer. In this row where there's no fertilizer, there is almost no sign of phosphate deficiency, even though none was added. Remember, the back row has got all the trace elements added with it. So he adds the fertilizer, and now what's the next problem? Phosphate deficiency, red base right to the ground. But hang on, that doesn't make sense. It had phosphate. This didn't have any phosphate deficiency. By turning the fertilizer off, if I go back to the things here, notice a few things. Where there is fertilizer, it's too vertical. Vertical is bad. Where there was no fertilizer, it's multicoloured. Two or more things are wrong. And it's about half the height. So phosphate's an issue, but it's probably not number one. And the plants tell you, fix up the zinc and manganese, and now it shows you the third problem. You don't learn that unless you turn the fertilizer off. That's why I want you to remember the most important thing of learning plant language is turn your phosphate fertilizer off at seeding time. I'll hammer it again. Turn your fertilizer off at sowing time and do a double dose next to it. And that's because of this. we can use technology to be very efficient farmers these days. If I come to you at harvest time, and I would come to you and say, did you use enough sulfur? You are not allowed to say, I don't know. You should be able to have a nil and a double in every paddock, pull out your yield map, and tell me, actually I could have used less, or actually no, I needed more. We have the technology to do that these days. So, learning plant language is coming to a website. It's taken me 9 years to make it, but it's nearly at the end of the road. It'll have a very, very detailed workshop thing of how to learn plant language, initially for wheat, barley, oats, triticale, canola, and then the other crops will be added. And I can come and run half-day workshops if you like. Sorry, that's just a little short version, but that's all we have time for today. So, thank you.
Wayne. Bueno, como les decíamos, por favor ahora vayan levantando la mano para que les alcancemos el micrófono. Así le vamos haciendo las preguntas a Wayne, por favor. Si había estado todo tan claro me preocupaba.
¿Con qué herramienta puede ayudarse digamos, a corroborar el diagnóstico que hace a través del signo que le transfiere la planta? La lesión que ve en la planta, el síntoma que ve, el color, ¿cómo lo puede, digamos, buscar alguna herramienta para corroborarlo?
Excellent question. If I saw zinc deficiency, I'll go back. In my early days, I would do a tissue test, and it would tell me it's zinc deficiency or not. But often I would look at it and go, that is zinc deficiency, but the tissue test doesn't show me because it's all over the place, because there might be 3 other things wrong at the same time. So the way I ended up confirming it was I would spray zinc. If it responded, it was zinc. If it didn't respond, it wasn't zinc. Copper, nitrogen, sulfur, whatever, that way. And it becomes very hard when there's 3 or 4 things wrong. But I can now tell what's the number 1, number 2, number 3. And hopefully you guys will one day too. I wish I had been taught this at university, because the real world isn't a textbook.
Si las condiciones climáticas, o sea, mucho frío, mucha agua, ¿puede potenciar estos síntomas? ¿Se entendió?
Yes. Sorry about that. I thought Spanish had lots more words than English. Yes and no. When a plant is stressed, it shows what's weak. So if there's a disease patch, for example, I go straight to those, because it will show me first what's the problem if there's a stress. It gets very hard if it's waterlogged. I don't take a lot of notice, because the number 1 problem is it can't breathe. All it needs is oxygen. So waterlogged crops are very hard to diagnose, because it's sick in everything.
Esa deficiencia de micronutrientes que has visto principalmente en trigo, después cuando cambias de cultivo a otros, ¿la seguís viendo a las deficiencias esas? ¿La podés diagnosticar en otro tipo de cultivo, a la misma?
Yes, I can, but excellent question. Let's take copper as an example. We might see copper in wheat and barley very easily. If the next crop is canola, canola doesn't really need copper. So knowing that, you wouldn't bother about copper that year. But if it was another crop that did need copper, we would add it anyway because of what we saw the previous year.
cómo ve los análisis de suelo, cómo se correlacionan, cuál es su opinión, la correlación de análisis de suelo con lo que muestra realmente la planta, ¿no? Siendo que un análisis de suelo es un método casi indirecto y la planta puede actuar de otra manera, ¿no? En la toma de nutrientes.
Another excellent question. You're all very good at this. For us, there is no correlation in a soil test for a trace element and what the plant gets. Our soil test companies do it, but there's no correlation between what the soil test says and what the plant gets. Yes, for phosphate, potash, sulfur, pH, etc. My strategy is this. A client buys a new farm. I don't know anything about it. We soil test. I want to know the pH, the phosphate, the potash, the sulfur. After that, I let the plants do the talking. Because as I showed you, by turning the fertilizer off, spraying it with herbicides that hurt it, I learned very quickly, better than what the soil test can show. The soil test might show I need phosphate. But by doing the nil and the double, etc., I can learn very quickly how much phosphate it needs. I can make an educated guess from a soil test, but I can do it better by watching the plants. So the soil test is only the first thing I do on a new farm, then I don't bother very much after that.
Sí, la disponibilidad de nutrientes en el suelo no significa que la planta lo pueda absorber. Puede haber problemas de raíz, problemas de estrés. ¿Por qué no pensar en análisis foliares, análisis de tejido en general y ver la interacción que pueda ser por causas biológicas o causas químicas?
You guys are excellent. Really good question. Number one problem for us in Australia is nematodes. So it's eating the roots, so the plant can't find the fertiliser very well. We use zinc a lot to make the roots grow. Even if we don't need zinc, you spray zinc, it makes the roots grow to get over the problem. So let's say your crop has nematodes and you do a leaf tissue test. It can be very confusing because the number one problem is something eating the roots, not what's wrong with the leaves. So I always check the roots first, and then I will let the plants do the talking after that. Not sure if I've answered that question.
Gracias.
Usted nombró diflufenicam como un herbicida que se puede usar para ver los síntomas. ¿Hay algún otro que haya usado y que tenga iguales resultados?
Yes, any graminicide, FOP or DIM we call them, they hurt the crop. So if it's not zinc deficient, it won't hurt it. If it is marginal zinc with no symptoms and you spray the herbicide, it will show the symptoms. You might have any herbicide like that or UAN. Again, if the crop's healthy, it won't hurt it. But if there's something weak, it will show it up. One thing I didn't mention about trace elements. You can lose 20% of yield with no symptoms whatsoever. So that's why I like to stress the crops a little bit with my recommendations to my clients, because it shows me what's wrong before the plant actually is ready to show me.
Aprovechen que son los últimos minutos. Bueno, ¿alguien más quiere preguntar algo?
Can you use the same plant language for the biofertilizer effects? If you use phosphate solubilizers?
Learning plant language is only really seeing what the plants are telling us. So what fertilizer you add is something different. I will be watching the plants, how they respond to that or don't respond. It both tells me something. It's a made-up name, learning plant language.
La pregunta es, el ambiente del oeste de Australia es un ambiente muy deficiente de nutrientes, entonces puede expresar cualquier deficiencia fácilmente. ¿Cree usted en estos suelos de Argentina, donde esas deficiencias no son tan acentuadas como en Australia, puede también enseñarnos algo de alguna manera, o eso es más difícil de distinguir o poder conocer?
No, much easier. Because you might only have one thing wrong, or two. I'll give you an example with Kansas. Kansas is the biggest wheat producing state in America. So first time I went there thinking, they're wonderful farmers because they produce so much wheat. But every paddock I went to had a problem. In fact, I went to a conference once and I thought, I'm never coming back here again. And I said to them, you're the most inefficient farmers I've ever met. Thank you. The reason being is because in 1970 they were doing about 2 tonne a hectare. Today they're only doing about 2.5 tonne a hectare. They haven't improved very much. So for you, because you have less problems, you should be able to pick it up easier. But one thing I teach in learning plant language is you've got to keep an eye on what's potential. So for us, I explained to a gentleman before, we have people doing 4 tonne, 5 tonne on only about 150, 170 millimetres of rain. We used to think that's impossible. So if you are receiving 400 or 500 millimetres of rain and are only doing 5 tonne per hectare, something is wrong.
¿Podría llegar a confundirse un síntoma de deficiencia de algún micro con alguna sobrefertilización, ya que es muy fácil pasarse con esos tipos de micronutrientes?
Yeah, with the toxicity. Not really, because toxicity has different symptoms again. I haven't shown you any. Because normally deficiencies are the problem, not toxicities. But we have boron toxicity, we have aluminium toxicity, but they are very different symptoms.
Bueno, última oportunidad para una pregunta. Bueno, le agradecemos de vuelta entonces con un fuerte aplauso.